Hello, my name is Kevin Lindegaard of Crops for Energy, and welcome to the second Biomass Connect webinar. Today we're dealing with emerging markets for biomass crops, in particular miscanthus and short rotation coppice willow. So before we get started, I just want to direct you to the Biomass Connect website. Here you will find all of the information about the news of the sector and all the events we're involved in, plus many other opportunities for knowledge exchange and learning. Next slide, please. But I also would urge you to sign up to the Biomass Connect newsletter. That will go straight to your inbox every couple of months and give you direct information about all these events and everything. Obviously, in order to get those newsletters, you need to sign in, opt in, and then you'll definitely get them. So today's is all about the emerging markets for biomass crops and trying to get the most out of it. For me, for a long time, I've felt that just simply burning energy crops like miscanthus and willow is a bit wasteful. And I've been wanting to see people to cascade uses together and make the most of the land, make the most of these versatile crops. Now, before we meet the luminaries that are going to tell us all about what's happening now and in the future, just a glimpse back in history to a couple of venerable chaps here, nice stout noses, a bit like my own. And Cato, who was a Roman gentleman, he wrote on the farming sector in ancient Rome and tried to discern what would be the best way of managing your farm. And he decided that a 100-acre farm should be divided 6 ways: into grain fields, an olive grove, a vineyard, an oak and beech woodland for pig production, a vegetable nursery, and an osier bed. So essentially a willow plantation. Now, almost 1700 years later, John Evelyn, writing in his seminal book, Silver, which is on forest trees and propagation of timber, he also mentioned the importance of willow to help with another crop. In this case, it was a vineyard, and he talked about a 25-acre vineyard needing a 1-acre crop of willow. Now, what is it about willow? What makes it so versatile? Essentially, it's a fast-growing tree that produces a lot of material in a very, very short time. So you can get things like basketry and hurdles and rakes and poles and ties for the espalier trees and ties for the vineyards. You can also produce fuel and charcoal, but also you can get pollinators into the other crops of importance. So that's a really important thing, and it's something that we really need to learn from. We need to take a leaf out of these books from history in the way that we tackle climate change and the net zero target going forward. So that's enough of the luminaries of the past. Let's move on to the luminaries of the future. Well, of the present, in actual fact. So today's talks are going to be done by Professor J.J. Leahy of the University of Limerick, who heads up the BioWill project. And also he's got a background in miscanthus as well as a commercial grower, but at the moment he's heading up this project which is looking at the biorefinery potential of willow. And also William Cracroft-Eley of Terravesta. So William is a grower of some repute and has headed up Terravesta for over a decade now, and they've been at the forefront in the world of miscanthus, looking at all sorts of different options. So we are going to go to William first, and we're going to fast forward to his presentation, and then we'll come back to Professor Leahy in due course.
Kevin, thank you very much, and thank you very much indeed for inviting me. So in your invitation, you were really asking me to talk about emerging markets and products for miscanthus, and I hope that I come somewhere near to satisfying that brief today. Next slide, please. So this sort of pictogram is one that actually I produced all too many years ago now, but it doesn't seem to go terribly out of date. So I leave it there. But before looking at that. I think it's very easy, and particularly when you're talking to people whose global experiences in other areas of expertise and fields and everything else, it's very easy to try to convey, or for people to think of products as something that either sort of sits on a shop shelf or comes via Amazon or the like through the post or whatever, and is something that is sort of tangible and usable and admirable and everything else. So we sort of get people talking about our poultry bedding, and we did a line of domestic fuel products and that sort of stuff, and it was easy to convey. But products, of course, are much more sophisticated than that. And so, on the one hand, you get the sort of one and obvious level, and the easy one to convey, of course, are all those tangible things. But then, the vast majority of products are the sort of intangible things. So whether that's in the energy you use, so you obviously can see from your light or whatever that you have electricity, but you wouldn't know whether that electricity was being generated by oil or gas or coal or biomass or wind or solar, because electricity is just electricity. So in terms of energy and services, or in terms of substitution, I could tell you that orange peel is used in the manufacture of car tires, and it wouldn't mean anything to you. I don't think it is, by the way, but it's just an example. So it is something that you don't see because it's just a component of something else. And of course, very much in this world, there's a product in the environmental services in itself, and that often is a co-product or a product the other way to the usable or more tangible products that can be got from biomass crops. So that's the point I make. Just turning very quickly to the pictogram, then the sort of bottom and right, the brown uses are those that are the ones what I call the first generation. So they're the ones that really everybody knows quite a bit about. Everybody knows about biomass boilers. Everybody knows about biomass power stations. And a lot of people will know about using alternative, whether that's shavings or whether that's miscanthus or whatever it is in bedding, and they what I call sort of single use and goes away, and they're great. They are important. They're important probably for the next decade at least, in terms of getting people switched over towards a more sustainable and renewable economy, and indeed in building confidence and volume. So the only problem with them is that they are not really efficient enough. So whether it's heat or power generation, an enormous amount of byproduct or potential byproduct is going up the chimney, and indeed with animal bedding, arguably you're making some sort of manure that can go back to the ground. But we need probably to be looking at things that are much more sophisticated in terms of the multiple uses you can get from it. And that really brings us then to what I call the second generation, which is where you get a number of different ones off the same use, and those are the green ones. So you might have fibres and materials at one end, growing the crop on land that is either contaminated or is vulnerable to contamination from other more intensive crops. And at the same time, you can be having a whole range of biorefined products from it, and all from the same material. And this is the way that we all have to look, and this is the way that we have to encourage everybody else to think about the sort of future products of miscanthus. It's not just about animal bedding and everything and electricity. So next slide, please. Far too long on that one. So to that end, Terravesta were very lucky, along with Aberystwyth and others, to have the opportunity to join the GRACE project back in 2017. It was a BBI EU-funded project. 21 participants, an enormous number of millions of euros, and it was intended to demonstrate cascade supply chains using either miscanthus or hemp, and it was into a range of end uses, bringing together the new novel hybrids and sort of agronomy at one end, and end use technologies at the other, to produce a huge range of products. And if you look at these, whether it's insulation and building materials, chemistry, including in those 5 chemical categories, really fundamental platform chemicals that go into all of the stuff of life, whether it's the paint on the walls or the elastane that holds our clothes on, or whatever it is, everything that you can think of is potentially on that list, and this is where we come into the sort of invisible product line, if you like. And it was demonstrating the processes. It was demonstrating how you get the different elements out of the basic crop and send those in different directions. That project is just drawing to a close. It's sort of it's at report writing stage and everything else at the moment. But it's fair to say, I think, that whilst you never expect to hit the perfect marriage between technology and optimum output and everything, first off, there were some very encouraging successes in that. There were also some failures, but that's inevitable. That's what science is about. But the successes will definitely be worth taking further and honing the raw materials, the feedstocks, and the processes to really produce efficient systems. So next slide, please. This is just a very quick one. In addition to those sorts of ones, we've got also compost additives, which are a massive issue now in terms of peat replacements and growing mediums for strawberries and packaging stuff. So that's a extra slide. Next slide, please. So the honing feedstocks, processes, and products is the really important part in actually making these supply chains take off, because obviously the thing will only work ultimately if there is a financial or value motive in this. And obviously, as you start at one end of the process, perhaps of the feedstocks, you have to seek to increase value. So in this slide, as you move from left to right, the value chain goes up. And so in terms of the feedstocks themselves, that is about getting hybrids that have the sort of right components, to produce good yields, so whether that's drought resistance or heat tolerance or frost tolerance or whatever it happens to be, or whether indeed that is in having desirable traits in the chemical and biological makeup of that particular product, and then it's about honing the processes to produce the right outcome and the most efficient product at the other end. But What this slide also does in very important terms is it doesn't actually describe which is the feedstock and which is the product, because in this low carbon economy, which is what so much of this is all about, the sort of, in a way, there's a product that heads the environmental products very often head the other way. So whilst the product could be anything from eco concrete to eco electricity or whatever it is, whilst that could be, in a way, the environmental product, that could be carbon sequestration, and so therefore you could end up with the miscanthus sat in the product side and the feedstock being the power station. So where perhaps you sort of look at this one way and you think, oh gosh, well, the trouble is the poor old farmer always sits at the low value end. In the environmental end side of it, it can be reversed, and that's going to be a very important part of the tale, because that is what is going to add value to these crops and make them something that people really want to grow. Next slide, please. So in terms of miscanthus waters, and in terms of using it for electricity, which is what we currently do, what does that really mean? Well, if you look at the sort of start with the power station picture on that little dial, we've got the power station burning miscanthus, which gives off CO2. Then the growing crop absorbs the CO2, and then you've got it coming round and round and round. But the growing crop is also putting carbon or CO2 equivalent into the soil, and that is long-term stored. So not only have we got a carbon neutral above ground cycle, but we've got carbon being sequestered, and in our life cycle analyses, given a sort of reasonable yield of miscanthus, we're getting roughly the equivalent of 2.35 tons of CO2 sequestered per year. That will obviously vary on soil type, but it does show that even on today's technologies, where we're not even doing carbon capture and storage, there is in this whole chain, there is net positive net sequestration. So next slide. Of course, if you add BECCS, you're getting a massive amount more benefit to that, because they're then also putting their emitted CO2 back into long-term carbon storage elsewhere. But that also means that there is still the value in the CO2 sequestration in the crop itself. Next slide. Carbon storage can take place in other ways as well, and that's important as well. And so BECCS is one that, you know, we all think and hope is going to come about, but actually there are others. There's building, and particularly whether it's miscanthus or whether it's timber, you know, storing carbon is a tremendous way of locking it up. So we talk about eco concrete or miscrete or whatever, and the Dutch are doing a tremendous amount of work on that. It was a very big part of the GRACE project as well. Here is a slightly more direct way of doing it, which is actually building houses of bales, and that's a different approach. It's low, it's maybe slightly lower tech, but you know, it does the trick. So storage uses are I think going to be important one way or another, particularly in the building materials, particularly with the concrete, because concrete is such a carbon intensive process at the moment that anything that offsets that is bound to be very attractive to that industry. Next slide. the other side to this is to the products and services is actually the environmental services that these perennial crops in particular can bring in all sorts of ways, and whether that's in land remediation, or whether that's in lowering soil erosion and hence heavy metal erosion, or whether that's in flood alleviation. There are all sorts of societal benefits and products that carry and should carry a value too, and it's very important that we all lobby and push DEFRA to fully recognise those in their very slow to emerge suite of new environmental services. Next slide. Just to help bring all of this to the fore, one of the great challenges is that if these crops, whether it's SRC or miscanthus, whatever, are to really play the role that they have the opportunity of doing, and that it's recognised in BAYS, we've got to scale these up to sort of the equivalent of major agricultural crop status. They've got to grow to something like the size of the area of oilseed rape in this country, for example, to really make a significant contribution. And they've got to do that in a very short time scale, because the whole net zero challenge is about controlling global warming and doing stuff, not sort of sometime in the future, but actually doing it today, so that we're up and running and flying by 2050, not just sort of getting there. And so a large part of this is addressing how we can do that, how we can operate more efficiently, how we can deliver innovations that are going to bring the cost of establishing these crops down, and make sure that the crops themselves and the establishment and the agronomy of the crops is improved to deliver maximum outcome and benefit from it. And to that end, we're very lucky, and we're very privileged to be part of the OMENS programme. So it's part of the Net Zero Innovation Portfolio, and that is something that we're very excited about, and is already starting to galvanise some interest, even though we've only just got going. But the learning from it is going to be very relevant to everybody. So do watch this space. Last one. So for us, we were 10 years. So we were actually 10 years old last year, 2022. Apologies for the slide. We sort of realised that if we wanted to move forwards with everything, then everything lies in development. We've, as a business, been massively committed to that. So breeding new varieties was part of a giant link project with Aberystwyth University. We've been working on novel uses and phytoremediation. We've been developing seed-based miscanthus genotypes and varieties, and looking at end uses. So the work goes on, and it will continue. It will continue long after this, and the outcome hopefully will be not just the promise of products, but actually the ability to really deliver the feedstocks on the ground for a really exciting range of supply chains, and a significant contribution to the bioeconomy. Thank you.
Thank you very much, William. That's great. I should say to everyone, there is a Q&A button at the top of the screen, so please put any questions that you have in there, and we'll address them after the next talk. In the meantime, I'm just going to ask William just one quick question. Is there one market you think that will take miscanthus into the stratosphere and turn this into a bona fide cash crop for farmers?
Well, I think in the end, I think probably construction is a tremendous opportunity. I think the concrete products are a tremendous opportunity short term, and I think in the end it will come in certain chemical products as well, because they have enormous value, and indeed they rely very much now on, they are, if you like, the oil sector that we don't really see because we don't put it in our cars or pick it up on the forecourt. So they stand to make it a tremendous contribution to our greening. Whether, and I say that rather than power, because my vision for power is that all of these other processes, cascade processes, will generate byproducts, whether that's gases or whether that's just residues, that then will go into power generation. And so in a way, the biomass power generation will become something that is incidental to other more valuable streams rather than the mainstream in itself. BECCS, of course, would change that in the short term, because it would speed the or raise the biomass power in the sort of overall power mix. But nonetheless, I think the real value in products lies elsewhere, with power becoming an incidental, albeit one that started as the main driver.
Great, thank you very much, William. So we're now going to hear from JJ Leahy of Limerick University on the Willow project, BioWill, which involves a cascading biorefinery. So without further ado, I'll hand over to JJ. Please take it away.
So basically, my name is JJ Leahy. I work in the University of Limerick, and I'm going to speak this afternoon about a project that we're involved in very, very much. And Kevin is also involved in this project and has a key role in the project. And the focus is on Willow. And the background, next slide, please. The background to this project is, as Kevin said, it's about a cascading use of a biomass. And the context is the European Bioeconomy Strategy, which was launched in 2018. And I'm based in Ireland, and in Ireland, we've had a number of schemes in order to get farmers to grow both miscanthus, and I was part of that scheme, and willow for power generation. And by and large, in Ireland at least, this has not been successful, primarily because the income that the farmers were receiving was very low compared to alternative farming enterprises such as dairy. So we looked at willow and the varieties of willows which were being grown in Ireland, and we endeavoured to find varieties which could offer to farmers a higher income stream. And so the focus for us became on willow varieties, which Kevin educated us on, which would grow in Mediterranean countries, the southern Egypt, for instance, but also in China. And these varieties had very high levels of what we call bioactive ingredients. So these are materials which can be used potentially in pharmaceutical products, but which also offer potential use and high value use as food ingredients and as phytopharmaceuticals. And when we looked at the European Medicines Agency's portfolio of products, we could see that willow extracts can be used in topical phytopharmaceutical products, and these include cosmetics, at concentrations of up to 5% without requiring medical trials, because this obviously becomes costly. So that's the background. So next slide, please. So within this project, we had the idea is that farmers will grow willow. And we have, as I said, we have selected varieties of willow which will grow well under Northwest European conditions. In our case, with the UK, Ireland, and Northwest France, but which also have high levels of salicin or bioactive molecules within the bark. So the concept of this is that the farmers will grow the willow, and you can see the slide on the left here, which represents the different varieties of willows, and you can see that the stem colors are even slightly different. So once we take the willow, we strip the bark from the willow, and we're now left with two products. We're left with a debarked willow pulp, and we have the bark. And using the bark, so the bark is key to these bioactive molecules. We use a process to extract salicins, as we call them, from the bark of the willow, and then we're going to formulate these into ointments for the treatment of dermatitis, and we have a company that's going to test these. The company is made up of rheumatologists who will test these for the treatment of psoriasis, eczema, and other forms of skin disease, because, as I said, it can be used topically at a concentration of up to 5% without requiring EMA, European Medicines Agency approval. With the remainder of the material, in other words, the debarked willow pulp, we are forging that into packaging materials, and these are biodegradable food catering products. At the end, so these would be used for fruit and vegetables in supermarkets, and in many cases within the supermarkets, which currently use plastic packaging materials, plastic trays. If you want to feed the waste into an anaerobic digester, you will have to separate the tray from the fruit product. Whereas in our case, the entire material can be used in an anaerobic, it can be co-digested in an anaerobic digester, producing biomethane, and then the residue or digestate is going to go onto the soil, and we're testing that for its nutrient value, which, if there are nutrients, it will come from the co-digested rather than the willow, but also for the recalcitrance of the carbon once it goes into the soil. Because the concept here is that the most volatile carbon will be converted to methane in the digesters, and any carbon remaining in the digestate will be recalcitrant. So if you put it into the soil, it will remain for a considerable period of time and may attract, potentially down the road, carbon credits. Next slide, please. So again, this just summarizes what we're doing without the pictures. So the farmers will grow the willow. We've selected varieties which have high salicin content, but nevertheless, which are known, or we've crossed these with varieties which are known to have high mass in Northwest Europe. We take so once we debark, we take the bark, we extract the salicin, and we produce ointments for dermatitis. Any residual bark can be used for producing catering products. At the end of the lifetime, they will go into an anaerobic digester. We produce biomethane, and the digestate then we're characterizing both for its fertilizer value and its soil carbon sequestration. Next slide, please. So we have a number. So we intended originally to take 39 willow varieties. We ended up with 36. We selected 3 geographical locations, one in Northern Ireland, one in Western Ireland, which was in an area where the soil was pretty poor, cutaway bog basically, and we also have a location in northern France. And these were in fact are the 36 varieties we eventually ended up with. Next slide, please. So this is the site in Loughgall in Northern Ireland. So we have the 36 varieties in each of 3 separate blocks, block 1, block 2, block 3. So these are 3 replicates, and this is the case on all 3 sites. Loughgall has very, very good soil. It has a deep organic soil. So this was the year we planted. Next slide, please. And this is the crop just before harvesting this year. So we're now in year 3, and in each of the years since we planted, except for the first year, year 0, we harvested the crop, we strip the bark, and we measure for bioactives content. We send the residue then to our partner in Bangor, and they're producing the products for us. At the end of each year, and Kevin can speak with this, we coppice the crops back down and we allow them to grow again, except for some. So, because one of the questions we're asking is, when is the optimal time to harvest if we want high bioactives content? So, separate from biomass yield, we are attempting to see, does the bioactive material change as a function of the plant getting older? So this is Loughgall. Next slide, please. This is the site in the west of Ireland. And you can see at the top of this slide, you can see how poor the land is. It's basically cut-away bog. So again, we have 3 identical replicates, block 1, block 2, and block 3, with the same 36 varieties. There was also a difference in terms of how these 2 sites were treated prior to planting. So in Loughgall, we sprayed using Roundup, we ploughed and we tilled. On this site, what we did was we used a digger or a tractor, and we just pushed away the top layer of soil. So it was essentially a no-till site. So we wanted to see if someone wanted to grow a crop organically, how it would perform. So this was year 0, or the year of planting. And next slide, please. This is the crop currently earlier this week, because we harvested on Tuesday and Wednesday of this week. And you can see there's quite a lot of grass. So management of this site, because of the way we pre-treated it prior to planting, it does require a lot more hands-on management. And in terms of overall yield, the site in Claremorris has not performed as well in terms of overall biomass yield. However, when we look at bioactives, and I put up some slides in a moment, we are seeing for certain varieties well, I won't say much, but higher quantities of bioactives on this site. So it does suggest stress, because it is a poor soil. Stress may be a factor in the production of some of these bioactives within the bark of the plant. Next slide, please. So once we harvest rods about 1.5 meters in length, and we strip the bark using a homemade device. And then the stripped bark, we collect some small samples for use in our for doing the extraction, at least at laboratory scale. And the residue, so the remainder of the bark, as well as the pulp, we ship to our partner in Bangor for making the catering, the trays and the other catering products. Next slide, please. So this is essentially what we do in the lab. We take the materials. A key thing here is the bark has to be removed when the plant is green, because what we have found is that if we allow the rods to dry or to dehydrate, the bark becomes very, very difficult to remove from the pulp. When it's wet, it simply peels off, and it's child's play. You can actually just, with your nails, you can strip the bark from the willow. So basically what we do is we chip it, we grind it, and then we solvent extract it. Next slide, please. And the solvent extraction unit is essentially a coffee machine, or a slightly more sophisticated version of it that you will find in any coffee shop. So we use relatively high temperatures, up to 95 degrees, and we use a mixture, in our case, of water and ethanol to extract these. And you can see this little vial in the middle. This is what we extract, and then we test these extracts for concentrations of bioactives, not just salicins, which are known to be a good anti-inflammatory, but other bioactives as well. Next slide, please. And this just shows some of the results, in this case from Loughgall, for salicin among certain varieties of willow. And you can see certain varieties are performing much better regardless of how we do the extraction. So we extracted with different ratios of water to ethanol, but certain varieties are showing high salicin content regardless of the extraction medium that we use. Next slide, please. So I should have shown a slide as well, beg your pardon, from Claire Morris. And for some of these varieties, the concentration of salicin is actually higher on the crops grown on poor soil. We saw that from year 1 and year 2. We already have we've just harvested year 3, so we want to see if the trend continues to year 3, or was it some environmental factor in years 1 and years 2 were particularly dry years in Ireland. So we didn't have a lot of rainfall. So is it the soil, and we have analysed both soils, or is it some other environmental factor which has given rise to the relatively high salicin content? Because the other thing about the site in Clare Morris, it dries out quickly. So we extract we take the extracts and we measure the concentration of not just salicin, but a number of bioactive materials. So the question then is, does this follow through in terms of actual bioactivity? Just because you have a high concentration of certain molecules doesn't actually mean that they will show high levels of bioactivity. So what we do then is we test the extracts using cell lines. And our goal is the skin, because the idea here is that we're going to produce topical creams and ointments that we can apply to the skin. So the first testing that we did was for cytotoxicity to see if these extracts are poisonous to cell lines. We tested for antioxidant, because antioxidant activity is very good for the prevention of skin deterioration. We tested for antimicrobial to see if there's some so would they prevent, are they antimicrobial, and would they prevent certain types of infections? We tested for wound healing, and we tested for anti-inflammatory behavior. Next slide, please. So in terms of the results that we have so far, the extracts are not cytotoxic. They do show, all of them, but to varying degrees, so show antioxidant activity. They show wound healing activity. They're anti-inflammatory. We're also testing to see if they act as a skin barrier in terms of ultraviolet radiation. That's ongoing. In terms of anti-inflammatory activity, there's certainly a very strong correlation with the varieties the varieties which show the highest level of salicins in the raw extract. There's a strong correlation with the anti-inflammatory activities. So down the road, we're going to move from cell lines to a 3D cell model. So with the best varieties, we are going to take the 6 best. We're going to test these using what we call 3D cell models, and then hopefully we will look at the molecular mechanism and try to understand how they're actually operating. And finally, there's going to be a cosmetic application, as I said. Next slide, please. So for the 6 best varieties from this year, we're going to do large-scale extraction. So we're going to extract about 40 kilos of each of the 3 of each of the six varieties. Beg your pardon. So these are essentially 3 pressure cookers that we're going to use for doing the extraction. And this work we expect it to commence next week. We have the material already. Next slide, please. So after that, and we've started this work, we're going to take the extracts, we're going to formulate them into creams, and then we're going to test these creams on actual patients. So at that stage, we will be able to we will know which varieties give the highest salicin content or bioactives. We will have a correlation between those and the laboratory skin testing. We'll formulate into creams, and hopefully at this stage, we will have a product that we will be able to bring to market. And that's the intention. Next slide, please. So the residue. So what we do with the residue is our partners in Bangor use a conventional process for the production of molded pulp packaging material. So we've been sending them both the residue of the extraction, but also the pulp material. And they initially take it, they hammer mill it. It goes through a process of steam explosion, disc refining, and this has been done at semi-pilot scale. We do some pulp molding, and then the packaging is formed using a thermoforming process to produce molded pulp packaging. To date, we have found that we get good results from 100% willow. We get better results with a mixture of 60% willow and basically corrugated cardboard material, recycled cardboard. It provides us with a material with improved mechanical properties, but nevertheless, it does demonstrate and unequivocally that the willow can be used as a substitute for imported sugarcane bagasse and other materials for the production of molded pulp packaging. And this has become important because supply chains are becoming shorter. So we saw during COVID and even post-COVID that supply chains are still not back in place. So there will be a need for local supply of biodegradable packaging material. Next slide, please. So one of the other outcomes from this has been that our partners in Bangor have also used the willow, the steam exploded willow pulp, as a substitute for peat for mushroom casings, particularly for high value mushrooms such as shiitake mushrooms. And we're actually getting surprisingly good results because as many of you will know, the use of peat in horticultural media has been banned since 2020. So we're now looking to an era, what we call beyond peat. And peat is the primary substrate that's used in mushroom casings in Ireland and the UK. So there is, this was a surprise to us, I have to say. It was not the original intention of the project, but it could be that the use of the pulp, or maybe you would use the material as a packaging, because we spoke, Kevin mentioned cascading, that we would have a series of cascading uses for the willow. So you might use the pulp, you might use the material as a packaging material. Post packaging life, you might then incorporate it into a casing material for the production of mushrooms. The part that I haven't spoken about, I'm going to finish in a moment, is the anaerobic digestion. So what we have seen to date is if we use 100% willow for anaerobic digestion, we get relatively low yields of methane. So you would expect from an anaerobic digester that you would get 60% methane and 40% carbon dioxide as a minimum for it to be profitable. We're seeing with 100% willow, the yields of methane have not exceeded 40%. So I guess what it does is it reinforces our original belief that we will actually have to co-digest the willow, which we're doing at the moment, using animal manure and food waste. So that's basically the end of my presentation, but I would be very happy to answer any questions.
Thank you very much, JJ. That's great. Sorry we can't see you, but good to hear your voice. So similar to the question I asked William just at the end of his presentation, could bioactives make willow a cash crop? So what is the price per gram of salicin at the moment on the open market? And how much salicin could you get from, say, a hectare of high salicin content willows?
It's a very good question. And for us, the key is, so we know what the price is for pure salicin. And pure salicin at the moment is manufactured chemically, and the cost is relatively low. However, when we compare pure salicin, and these were just laboratory tests, but they're also in vitro testing of which not by us but by medical personnel that validate this. If you use a crude extract, it's actually much more effective at reducing inflammation than a single molecule. So I would see the value of willow both in dermatological creams, but also as a food ingredient, because you can drink this, because the way we're extracting it is water and ethanol. So would I see a business model? The business model I see is this: that we could grow our varieties of willow, the varieties you selected, Kevin. They have, for Irish farmers, they have a multiplicity of benefits, because for livestock farmers in particular, I mentioned Irish farmers, but livestock farmers, because livestock farmers have a particular issue with nutrients. We tend to use, they use excess of nutrients in the production of livestock. This is causing severe pollution of rivers and lakes. What we know from work that one of our colleagues has done is that if you grow willow varieties along rivers and streams, that they absorb a lot of the phosphorus and they significantly reduce the pollution of rivers and lakes. So if you were to grow coppicing crops such as willow with high, with the potential for high salicin, then there is a very, very strong potential for a viable business for farmers, because they're getting the benefit of reduced phosphate runoff. They're getting a cash crop, which they're not, and a crop which will provide them with revenue. And we're actually speaking, and we're hoping that we will have a follow-on large pilot scale project involving a dairy processing company in Ireland and a group of basically a farmers co-op, a dairy co-op, we are currently developing the business model, and Ernst & Young are doing the analysis for us. So we expect by June that we will be able to provide, and we will put this out in the public domain, that we will have validated numbers on different scales and different potential uses of high salicin producing varieties of willow.
Great. So watch this space. I guess when that information is available, we'll be able to put it on in the Biomass Connect newsletter. So thank you very much.
And I would be, and thank you for the opportunity to disseminate now, but certainly we would put this in the public domain.
Brilliant, excellent. So I've got a question for William now. Of all the uses of miscanthus, I'm assuming that the life cycle analysis is going to be as good, if not better, than bioenergy, just pure bioenergy. Which one has the best life cycle analysis in your opinion?
Well, ultimately, any of the storage uses again have the best life cycle analysis, I guess, aren't they? Because if you take the whole crop end to end, but that's not to say That's not to say that that's necessarily always the right thing. You know, there is this sort of clearly defined sort of scale of sort of desirable outcomes, but you know, the reality is that so much of the stuff that we need to live today, whether that's fuels or whether that's other products or whatever it is, environmental services, you know, we need to be able to decarbonize it all if we're going to make if we're going to make our targets. So I think you need to be very careful about being too picky about what's there today, because actually what you want to do is encourage new technologies that'll make the most of it tomorrow.
So if you use miscrete or straw bale in a building, would you say that is carbon locked in situ for 100 years or 50 years, or what would you think?
Well, in theory, yes, it is. It of course depends on all sorts of other factors, like how good the building turns out to be, doesn't it? You know, there's plenty of stuff that was built when I was a child that's now being knocked down because it seems being so. But you know, yes, I think it is. But as I say, I don't necessarily think that's the only, or indeed necessarily the best, because you could do that maybe with other products too, whereas miscanthus could have, or willow could have, as well as we've heard, willow does have, you know, particular other properties that you know lends it to other uses. So I think you need to just be very careful about it.
Okay, I've got one more question for JJ, and then I've got another one for you, William. So JJ, because this Biomass Feedstocks Innovation Programme, which we're all funded by, Biomass Connect project is funded by, is a lot of it is about innovations. I'm just wondering if there is an innovative piece of machinery that is available at the moment for stripping willow.
This is a challenge. We have the requirement to strip the bark from willow necessitates that, as I said, that the material is wet when it's done. So most of the machinery that is being used semi-industrially, it's still almost cottage industry, you know, and there's a gap in the marketplace. And if I was to see a single large obstacle for the willow bark industry, it's the lack of mechanization for bark stripping. There are certainly machines out there, but these machines are from the 1960s and 1970s and even earlier. There's been relatively little innovation, and a lot of it is because of the relatively narrow width of the willow stems. You know, it's debarking of birch, which is it's routine, but birch has a diameter of around 30 centimeters. Whereas debarking something as narrow as willow imposes a particular challenge. And I would say it is the gap that really needs to be addressed.
Okay, we've got another question from Edward, who has we kind of addressed a bottleneck there for the extraction of salicin. Is there a bottleneck in the processing of miscanthus for some of these uses? Are there any technical challenges, William, you can foresee?
Yes, I mean, I think the big one comes perhaps in the refining world, really, in that and it's around lignin and therefore the ability the effect that has on locking up certain elements of the crop. So what is the way around that? For sure, I suspect there could be processes that assist with that. So whether that's using acids or whatever it is, but we also believe that and we've seen evidence that part of it lies in developing hybrids that are lower in lignin and have more easily have more easily accessible chemistry. Whereas, of course, conversely, possibly for the fibre uses and in particular for the sort of what I'd say phase one uses, the burning type uses and stuff. Actually, the lignin's useful, but it comes that in my view comes back to having not trying to have one solution fits all. We need different crops for different purposes, possibly.
So to draw an analogy, I think with the fossil fuel industry back in the 1970s, we were always, or when I was a kid, we were hearing things like how much oil is left, and of course, as the price of oil went up, more was available because it became more economic to drill for it. And I think this is the same with Willow miscanthus. As the price of these crops and all of these additional uses that goes up and makes more money for farmers, the economics will stack up for much more innovation, and these sort of things will come forward. Thank you very much, JJ and William. I really enjoyed your presentations. If I could have the next slide, please, and I'll just do an introduction to a couple of things that we've got coming up. So on the 7th and 8th of February, we're going to be at Stoneleigh. That's the Biomass Connect team. There will also be plenty of other biomass feedstocks innovation program projects there, including Terravesta and EnviroCrops. So please come along and talk to us. There's lots of seminars and plenty to enjoy. And the next slide, please. And just an intro for the next webinar, which is going to be on the 23rd of February, so next month. And we're dealing with two different types of energy crops, really. One that is very short term in a way, described by John Hawkins of Bagber Farms as a poor man's energy crop, because you can plant it and get a yield very, very quickly, and it's cheap. And then the other longer rotation, or the short rotation, but slightly longer in terms of getting a result from eucalyptus, and therefore you're producing tremendous amounts of biomass in a relatively short time, but very high quality. So I'm really looking forward to those speakers on the 23rd of February. Obviously, please join in advance by registering on the website. So I'm going to draw it to a close now. Thank you again, JJ and William, for very, very illuminating talks. And I look forward to seeing you all at the next one, webinar 3 on the 23rd of February. Thank you very much.